Welcome back for another tutorial of physics. This number 61, we have to use some formulas, and if you want to go deeper, you can understand what's the role of the current on this on the formula of electromagnetic field and the magnetic field. So first thing first, we gonna use the Poynting vector formula, and that's electric field multiplied by the magnetic field divided by the constant. We need this formula to prove that the Poynting flux from a resistance is going to be equal to current square multiplied by the resistance, and that looks like mostly like a power thing. So they say to use the integral of the Poynting vector by the area. Okay, so do some research to understand at least the base of how this thing works, and you can come up with some understanding of how things work. So I'm gonna tell you how did I came up with from this formula to this. We know that's Poynting vector, or let's say I'm gonna divide it by one side. Electric field is equal to the resistivity multiplied by the density of the current, and we know the magnetic field is equal to the constant multiplied by the current divided by the area. Okay, so let's put these two formulas in the Poynting vector, and that's 1 over constant resistivity density multiplied by constant current divided by 2πr. Okay, so now this side will cancel out, and we're gonna use the resistivity. Resistivity is equal to resistance multiplied by the area divided by the length multiplied by the current. Actually, don't forget the multiplied by the current density multiplied by the currents divided by the area. So the area will cancel out in this side. What are we left? Poynting vector is equal to the resistivity density is equal to current divided by the area multiplied by the current divided by length. And if you integral the Poynting vector, we're gonna have the derivative of the area equal resistance multiplied by current square.